this improper?
Because it puts a negative inside the square root.
Where does that become a problem? The denominator.
So
Not at 0, right? Cube root of -1 is -1. That's okay. What value along that region, the interval from 0 to 9 causes trouble? 1. Does everyone see it? So I have to admit myself, sometimes you look at a problem like this, you might have to look at it for a while. Why is this problem in section 7.8? What's this doing in here? It's like, there's no infinity symbols here. But we see this expression with this cube root with the variable x in the denominator. We know you can't get a value of 0 in the denominator. And the value 1 inside there for x makes this expression undefined. So to start out, we're going to have to break this up into 1, don't we? So our setup, we'll start like this. 0 to the 1, right? I'll start here. I'll put the limits in a second. And then go from 1 to 9. We'll start here. But that's our first step, and then we'll put down the limit expressions. But I'm breaking it up at 1. I have to because that's where the trouble was. That's where this became undefined. It wasn't so obvious at first, though, was it? Cool. Hey, don't be like me when I was a student. I started looking at this, and weren't we talking about patterns earlier in this class? We were talking about patterns. Don't be like me. I was like, oh, I'm going to use that pattern, but that only works when it was towards infinity, remember? Now this isn't towards infinity. This is just 0 to what? 0 to 9, because I'm thinking before. So before I would have said, if this had an infinity on here, I'd be like, oh, I recognize this. If it went from like 2 to infinity, I'd be like, this thing's likely going to diverge. When that power is 1 or lower. But because it's 0 to 9, that's not going to work here. We're going to have to play this thing out. So far, so good? Now watch what I do when I write these limits. Limit, as t approaches, the trouble is where? 1. 1 and, here's a, we're going from 0 to 9, right? So I'm going 1 from the left side. And then this one we're going to be 1 from the right side. So I'm going to put 1 from the left side here. So I put a 1 dash, and I'll go 0 to t. Let me make sure we can see that and erase this with this eraser so it's very clear. I'm putting a -4 from the left side. But again, Connie, you were talking about this earlier, it's not a big deal. In the end, we're going to plug that 1 back. I know, that's what it means. But when this is 1 from the left side, because I went from 0 to 1. 0 to t, 1 over the what? Cube root of x minus 1 dx. And then this one will be plus the limit as t approaches 1 from the right side of t to 9. X minus 1 dx. Man, we'll see how this plays out. Does this converge or this diverge? Well, don't let that left side, right side bug you. It's all about in the end, we're going to go back and substitute 1s in there. We want to know, do you still get a 0 in the denominator? Once we do the antiderivative, that's what the trouble's all about. Let's find the antiderivative. But if you still get a 0 in the denominator, it's over. We're going to put this thing diverges. Okay? So don't let these kind of problems bug you. I'm just going to get the antiderivative of this. You can do a u sub, but you let u equal x minus 1. What's the derivative of x minus 1? 1. So this just becomes, you can think of this as 1 over u to the 1/3 power. So what would that integral be? This would be, so that's u to the negative 1/3. And when you take the antiderivative of u negative 1/3, what do you get? U to the 2/3
times 3 halves.
times 3 halves. And I'm going to put my u back. So I didn't have to write out that u sub part, because do you agree, if you let u equal x minus 1, what's the derivative? U equals x minus 1 with respect to x, just a what? 1, I put it back. So there's the antiderivative, and where am I going? From 0 to t? Was everybody clear with that antiderivative? Yep. And then we're going to plug in, don't let this bug you, 1 from the left side, all right, plug in a 1 when you get to this, and plug in a 0. Then we'll do this side. Let me flip. limit as t approaches 1 from the left, 3 halves, parentheses, t minus 1 2/3, minus the limit as t approaches 1 from the left of a 0 of all that stuff. 3 halves, 0 minus 1 to the 2/3. Okay, what's the cube root of negative 1? Negative 1, but what's negative 1 squared? 1. So I'm going to get a positive 1 here. This is coming out to be minus 3 halves. Cool. This is what I'm worried about. Now this one part right here is be common. That's negative 3 halves there. What about this guy? So don't let this bug you at all. You go, what? Oh, this is no. Just plug a 1 in there. Just plug in a 1. Don't worry about that left side, because it is approaching 1 from the left side. But we're saying as long as we can plug a 1 in here. The trouble would have been if we had a t in the denominator. I don't see any t in the denominator. What's 1 minus 1? 0. 0 to 2/3 is? This is 0. Very cool. The left part converged, and it converges to negative 3 halves, right? But we do have to check the what. I'll make a note that when that's negative 3 halves, it does converge. Make sure everyone sees that. Is everyone okay with this? That's a 1 from the left side of a constant. This is negative 3 halves because negative 1, the cube root of negative 1 is negative 1. Negative 1 squared is a positive 1, but there's a minus here. Or hit it on a calculator. But this turned into 0, didn't it? Nice. Hey, I was pretty sure this was converged because when we found this antiderivative, I didn't have any x's down here, did we? That's the secret. See, if you had an x down here, and then you would have applied a 1 in here, and you got a 0 down here, it would have been over with diverged. Hey, what's that in this? This should be similar. Limit as t approaches 1 from the right, and I'll write down the same antiderivative, which will be what? All that, 3 halves, x minus 1 to the 2/3. From a t to a 9, let's see what we get out of that mess. So you got to plug in that 9. Well, let's plug in over 9 here. What is 3 halves? 9 minus 1 is? 8 to the 2/3. Subtract, limit as t approaches infinity. Oh, I wrote infinity. Limit as t approaches 1 from the right. Of t minus 1 to the 2/3. Well, again, what happens here? Substitute 1 in there. What do you get? There's no denominator with a t in the bottom, not causing any trouble. This is going to 0, isn't it? 1 minus 1 is 0. 0 to 2/3 is 0. That plus is not going to bug us at all. The trouble would have been if we had, like, if this expression was 1 over t minus 1. Then you would have said, oh, 1 over 0 is undefined, diverges. Can you help me do this number? Cube root of 8 is 2. 2 squared is 4, and then I need 4 times 3 halves. 6. So the right side converges to? 6. So the final answer, what's negative 3 halves plus a 6? I'll write it right here. What's negative 3 halves plus 6? This improper integral converges. I'll put it right next to this though. Right here. It equals negative 3 halves plus a 6, which is a common denominator.
9 halves.
9 halves. Converges. Pretty cool. I really had no idea as well when we looked at this originally. I had a hunch it was going to converge once we got the antiderivative up. Because once I got the antiderivative, I didn't have any x's what? In the denominator. Cool? So you can brainstorm it. Now you can start thinking of problems like this. What would it cause if we did this, pump it up by 1, where this would have stayed down the denominator? X to the 1/3, is it be higher than the what? X equals 1, good, Kate. you have a question?
Yes.
Oh, go ahead.
I was gonna ask, is there any problems like this that one side converges and one side diverges?
You could get a problem like that. Absolutely. And the best part is, you go up, it diverges. So if you got one part, yeah, if one side converges and the other side diverges, put diverges.
Oh,
Or my favorite is when you split it up and, well, they both diverge, but you just did one side of it and you got the diverge, you don't even have to work the other side, do you?
yeah.
It's like he was saying earlier, like this thing's got to diverge. Diverge.
Thank you.
You got it. Hey, can we do one more? Just because I want to make sure everyone's comfortable with this antiderivative. In fact, this came up with someone's partial fraction problem. All right, last one. Here it is. I want to get one like the homework. It's got 0, it's got negative infinity, but it's got a 1 over 3 minus 4x. My main reason for picking this problem, something like this came up in one of the partial fraction problems, and the student wanted to know how to figure out the integral of this. That's a use of it. What do you let u equal to? Yeah, so before we even talk about put lim t, it's like, to work out this problem, we're going to be letting u equal to just the 3 minus 4x. And the du will just be the what? Negative 4, and you'll get a negative 1/4 du equal to dx. Do you see that? I just wanted you to observe that, so you're like, that's probably the hardest part of this problem. Not the new lesson today with improper integrals. How you evaluate these limits. Really that right there. So this happens sometimes in section 7.4. If you did all the homework practice problems, one of them has something like that, and you go, okay, I'm going to get we'll talk about that antiderivative. We'll put this back in there. All right, I'll write it out. Limit t approaches the negative infinity, t to 0, 1 over 3 minus 4x dx. Well, this antiderivative will be negative 1/4. Well, before I do it, I'm going to do 1 over u. What's the integral of negative 1/4 1 over u? What's the integral of 1 over u? There you go. Natural log, I'll put the bar as u. What's u? I'll resubstitute. I get negative 1/4 natural log of 3 minus 4x. So far so good? Hey, before you were telling me about how 1 over infinity goes to a 0, right? But e to infinity is infinity, right? Natural log of infinity is infinitely large, true? Natural log of infinity is infinitely large. E to the infinity is infinitely large. Just be careful, that one problem we had 1 over e to a. That goes to 0, right? All right. So I get this, and we're going to limits for t and 0. All right, let's start out. Plug the 0 first. I get the limit as t approaches negative infinity, negative 1/4 natural log of 3. Hey, that's just a number. We got that so far. Yeah, but it's all about the second part. Subtract limit t approaches negative infinity, natural log of 3 minus 4t. So what happens when you and I substitute a negative, infinitely large negative number into that, and there's a minus sign? It becomes infinitely large and positive. What's the natural log of an infinite large positive number? Infinity. I'm sorry everyone, while that was a constant, This is going towards infinity right here. What's the answer?
Divergence.
And I'm gonna say like you said earlier, the minute I know this thing's diverging, I just put it. I don't have to keep writing. Isn't that diverging? I put that in there. Minus 4 times, just think like negative a trillion. Negative 4 times negative trillion, right? Is that 4 trillion positive? You're like the natural log of an infinitely large numbers, you know, it's approaching towards infinity. You just think of the natural log of that. Cool.
Would that final number be positive infinity?
This right here, it's a minus in front of this, which went to positive infinity.
Wouldn't it be multiplied by the negative one?
So you're right, so this right here, so you go negative infinity in here, which is negative 4 times a negative infinity, you think infinitely large positive infinity. Natural log of a positive infinity, right? Because now you've already taken care of this. Natural log of positive infinity is infinitely large, so that's this, and then this just stayed there. Want me to do it again?
The 1/4. What about the negative 1 over?
Yeah, you forgot the negative one.
Oh, the negative 1/4. So I got you this thing right here. He's saying I gotta put it with it. So we're good, it's gonna diverge, but you're exactly right. I'll put this here. You got this negative 1/4, then subtracting 1/4 here. So up at the minus 1/4 there, but this became what? All this was still what? Infinity. So now you got the negative 1/4 times an infinitely large number. Still what? Going towards that? Cool. But I'm with you in terms of the subtraction of the negative 1/4. I'll write that again. I wrote it here, just so we're clear. Minus 1/4 ln of 3. Subtract, limit, t approaches infinity. There's this negative 1/4 right here. Negative 1/4. Natural log. 3 minus 4 times, and I substitute a t, right? So now we put this in here. This becomes, this was negative infinity. This becomes a positive infinity, but you're right. Subtraction of a negative infinity will now turn it into what? Positive infinity. Infinitely large, but it diverges. You don't even have to put towards infinity. But thank you very much. He's saying don't forget about that minus 1/4 there.
If we did leave a negative infinity, that's.
Oh, that's fine, because the best part of these problems, and it goes back to what he asked earlier, their directions, they say determine whether it was convergent or divergent. So you're saying, hey, this is divergent.
Okay.
That's most important that you recognize this would be an infinitely large, either positive or negative.
Okay, so
And you'd be fine with that.
the correct answer is divergent, not.
That's right, this is all, and you look, it's funny, look at, I call back a book Bob, guess what they write? They don't say diverges to infinity, and they don't write diverges to a negative infinity, they just write diverges. The only time you gotta put something down with it is it's what? Convergent. And that's the same for the test. So again, like, hey, as you're wrapping up, packing up there, he mentioned earlier, remember this? I keep using 1, I'll use 2. But if you recognize something like this, like right away, and you go, he's saying this thing has to be what? Diverges. Because this was what? This right here was less than or equal to 1. And that would be fine, but you know, I'm sure he was asking about this. I know he knows how to do that antiderivative. I know he knows how to plug this in. So he wants to say, I recognize that from what we discussed in class. And that's pretty daggone good when you're going to retain that. So I'm going to put this was divergent because this value was less than or equal to 1. Hey, in chapter 11, they call these p-series. These things when they're written with summation. And that's x to a p-value when that p-value is less than or equal to 1. So what would happen with something like this? To infinity, here I'll put a 3 in the numerator this time. Or I'll put a 30 dx, but this is x to, I'm just going to go over a 1. 3/2. What will happen? Yeah, it's going to converge. The whole idea is it's because when you deal with this antiderivative gets something up in the numerator. This antiderivative still leaves you x hanging down here, which makes it go towards 0 when you go towards infinity, the expression. Cool? I'm going to write converges. You know, we kind of want to wrap up class today on this stuff. Converges because this baby was what? Right here was greater than 1. This becomes essential again in chapter 11. So So when you hear stories about how bad chapter 11 is with series, they're not that bad. But boy, knowing these improper integrals is huge, it really helps. Cool. Hey, that's it. Hey, while you're wrapping up, yeah, you can stop it.